Hello. Now let's move on to part B of this question. This is chapter 17, question 74, time in a restaurant. The owner of a pizza restaurant knows, in France, knows that the time customers spend in the restaurant on Saturday evening has a mean of 90 minutes and a standard deviation 15 minutes. He has read that pleasant odors can influence customers, so he spreads the lavender odor throughout the restaurant. Here are the times in minutes for customers on the next Saturday evening. Okay, so here's the raw data right here. You can see that it ranges from 76 minutes up to looks like 130 something minutes. I think is the highest, 129 minutes. A lot of the times are in the hundreds, so it looks like the lavender does have some effect that it is causing people to stay at the restaurant longer, at least up to 10 minutes longer or so. But that's just a quick hunch just from a quick scan of this. But anyway, let's go to part B. It says, suppose that the standard deviation sigma equals 15 minutes is not changed by the odor. So it used to be 15 minutes. Let's say it's still 15 minutes. Is there reason to think that the lavender odor has changed the mean time customers spend in the restaurant? Follow the four-step process. All right, so first of all, this is a hypothesis test question. And how do we know that? Well, anything that asks for is there evidence of something, or anything that asks for a yes or no question, that gives you an indication that it's a hypothesis test. And in this question, it's asking, is there reason to think that lavender odor has changed the mean time? So that's a yes or no question. And then, just in case you're not sure, here it does in the very last sentences, it says, follow the four-step process for significance test. So anything with the word significance in there, is there evidence at a certain level of significance, or do a significance test or something like that? That's another clue that we're doing a hypothesis test. So that means step one, write the hypotheses. Step two, get the data. Step three, do the analysis. Step four, do the conclusion. So what's the hypothesis here? So the null hypothesis is that the answer is no, that the lavender has no effect. Let's put it in words first here. So the lavender has no effect on how long customers stay in the restaurant. So back to the original problem here, it says, here it is, it says that this pizza owner in France knows that on a typical Saturday evening, there's a mean of 90 minutes that the customers stay in the restaurant. So if the lavender has no effect, then the mean would still have to be 90 minutes. So there's the null. Now the alternate is either going to be the mean is greater, less, or not equal to 90. And we have to go back to the question here. The question says, the keyword is changed here. It says, is there reason to think that the lavender odor has changed the mean time customers spend in the restaurants? So it's not asking for an increase, although if you look at the data, it does look like it's an increase in the amount of time people spend because of the lavender. But it's not asking for an increase. It's just asking for, is there a change or not? Because I suppose it could have the reverse effect that the lavender causes people to leave early because they don't like the smell, perhaps. So because the question is, does the lavender change the length of time, the alternate is mu is not equal to 90. That indicates it's a two-sided test. I'm just making note of this. We'll need that for future reference. And then that means that whatever p-value we get, once it's time to get the p-value, once we look up the number on the table, we have to times it by 2, because on that sampling distribution, that normal curve, we've got possibly, if mu is less, we look up that side. If mu is more, we look up that side on the alternate. But in this case, mu could be more or less, so we have to look up the p-value and then times by 2. All right. Also, one last thing in step 1 here. Let's decide what alpha is going to be. It doesn't say in the problem, so let's just do the standard 0.05. Okay, step 2, that's the data stage. So x bar, we need to download that data and calculate that. Sigma, that's given to us. It says in the problem, back to the problem here, it says sigma equals 15 minutes. So let's write that down here, 15 minutes. And then n, if you count up the number of individuals, let's go back here to the problem. If you count up all the individuals here, it's 30. So n equals 30. Okay, so what does that sample mean? I downloaded the data right here, and just to save some time, let's just use Excel to do the calculation for us. So I'll do the average command, average cells A2 to A31, 105.7. Okay, so our mean 105.7 minutes. Okay, now already I'm starting to think I'm going with the alternate here. I think this null, based on what I see so far, I think this null is going to be false, because look how much larger here. The sample mean is over 15 minutes longer than what the null is suggesting right here. So just by that comparison, that's a pretty good indication that the null is false. But of course, like always, this sample mean could just be just random chance. I just happen to pick a whole bunch of slow customers in my sample, and maybe the real population of millions of people who go to these French pizza restaurants that have lavender in them, maybe the population still does 90. But anyway, let's finish the analysis, and then we'll know for sure. So step 3 is the analysis stage. We have part A is what is that standard deviation of the sampling distribution, so sigma over square root of n. So that's 15 over square root of 30. And just to save a little time, you've done that calculation lots of times in the past here, so just to save a little bit of time, let me just do that real quick. It's 2.739. Okay, so all I did, I just took square root of 30, which is about 4 point something, 5 point something actually, and then divide it into 15. I get 2.739. Okay, now part B, what's the z-score? So how many standard deviations is this sample mean above the hypothesis of 90 minutes there? We can use a normal distribution here. We can assume a normal distribution. We talked about that in part A. So anyway, let's just do the calculation. So it's x bar minus the null hypothesis mean divided by the sampling distribution standard deviation. So that is 105.7 minus 90 divided by 2.739. I already did that, 2.739. The sigma over square root of n. So that's going to be 15.7 divided by 2.739. Okay, that's going to be a huge z-score here. 15.7 divided by 2.739, 5.73. Okay, a huge z-score. So that what that tells us is this sample mean, 105.7 minutes, was such a huge sample result compared to what the assumed mean is of 90, that it's more than 5, this number is more than 5 standard deviations of the sampling distribution higher than this number. So that's, if the null was true, this would be a very, very remarkable sample mean indeed. So that number, 5.73, is not even on the table. If you go to the table in the back of the book and look up, you're not even going to find it. So that tells you that the p-value is essentially 0. Now, of course, it's not exactly 0 because nothing's impossible, but it's so close to 0 for all practical purposes, it's just 0. Now, this is just a technicality, but it does make a difference in other problems. So I just want to point out here, it is a two-sided test, so you have to take that p-value and times by 2, because I need to be concerned with less or greater, the lesser tail or the greater tail, so times by 2. But of course, if p-value is 0, times by 2, anything times 0 is still 0, so it's still 0. Okay, so the conclusion. The rule is if p-value is less than alpha, then you reject the null hypothesis. And that is the case in this one. P-value is way lower than alpha, so my conclusion is reject the null. And then in words, what does the interpretation mean? It means there is evidence that the lavender does change the length of time. So I'll just say lavender odor changes the amount of time people spend in the restaurants. Amount of time people spend in restaurants. Now, technically, it's restaurants, pizza restaurants in France, but I'll just stick with that, with this, in restaurants. Okay. Now, I could take this a step further if I really wanted to. I could probably say there's evidence that the lavender odor increases the amount of time. But if you go back to the original question, it wasn't asking that. The question was just, does the lavender odor change the mean amount of time? And so I'll just to be safe, I'll just stick with that answer as just it changes the amount of time. And that's it for that question.